Right, good morning everyone. Morning, morning. Well done for getting in here for not long after 9:10. And yeah, welcome everyone to the second day of the 25th Annual Leakage Conference. So I'm picking up the baton from Bob Taylor, who chaired yesterday. Thank you, Bob. And we had a really great start to the conference, really positive start, I thought. So a warm welcome today too to everyone here in Birmingham and to those of you joining us online today. And yesterday we heard a lot about the leakage imperative, if you like. Not just about good asset management, customer perceptions, 50% by 2050, 13% by 2030, but we heard around why leakage is important for maintaining the supply-demand balance, for keeping the taps running, for enabling environmental improvements, and for facilitating growth. A couple of reflections that I had on yesterday. Ian Pemberton talked about Ofwat receiving kind of one key number, and that same number is the number that we give to our other regulators, like the Environment Agency. It's the number that the media pick up on, and that, of course, is net leakage. And therefore, when we compare years to years, we're talking about the net leakage reduction. But of course, the gross leakage reduction is many times higher than that. And it's the gross leakage reduction that represents the collective efforts of the 200 people in this room and the many thousands of people working on leakage outside it. So how do we tell our story? This is going to be a key thing in terms of sort of changing the narrative. And who is going to tell this story? This feels like a key role for the Next Gen Forum. And we also heard yesterday about climate change. It feels a little bit like kind of rolling the dice. And this AMP, we rolled the dice, and year 3 came out with climate change on it. And it was significant. There was a lot of phrases used. I think the word unprecedented was used an awful lot in 2022-23, and of course it was. But here's the fact. The dice is loaded. 2022 wasn't a one-off. Before long, it will be twice and maybe then 3 times an AMP. So how are we going to adapt? I was struck by Jez's observation that we're trying everything before mains replacement, and I think that's right. It makes a lot of sense, both from an economic and a customer perspective. But is it going to be enough to deal with climate change? Mains replacement is going to have to be a significant part of the mix. So where do we target? Do we do the oldest bits, the easiest bits, the most climate vulnerable bits? And how we do it is also critical. We heard yesterday about the importance of high quality workmanship, innovation in materials, the way we lay pipes. Do we need to dig? And we've got to think about future-proofing. If we're going to start replacing mains wholesale, what about designing in access points that we heard about yesterday? And importantly, what about customers and customer supply pipes? We've got to do the right thing by the people who pay the bill. So today we continue to focus on important issues, trends, and emerging technologies. As Bob highlighted yesterday, these discussions and sharing of knowledge are even more important when our performance is under such forensic scrutiny. And that is why coming together, collaborating and sharing knowledge is so important, as the challenges we face cannot be solved alone. Yesterday's session closed with some insights into some of the leakage-related Ofwat Innovation Fund winners, and we will hear more from another fund project today. Yesterday, we also heard about some of the valuable leakage research being undertaken in our universities, which will support better understanding of assets performance. And today, we're going to start with a focus on repairing and mending, the M in PALM. This is an area where there is significant spend allocated in our AMP8 plans, and it is one of the most difficult as we try to fix quicker, cost-effectively, and with the least disruption and impact for our customers. And after that, we're going to move on to case studies focusing on operational and technological developments. And then we'll close our day with a session on upstream leakage, which is going to be a key area for us in the next AMP, as Ofwat's expectations are for us to be more proactive in this area, and, as we heard yesterday, to move away from the BABE analysis. So a broad-ranging day that we have ahead. Now, before we start the first session, I'd like to extend a very warm welcome to our exhibitor supporters. They're on the screen here: Aqualogic, BERMAD, CLA Val UK, Field, Gutterman, Horizon Water Infrastructure, HWM, Avaro, SME Water, Suez, Synthotech, Technolog, Tetra Tech, RPS, and our media partner, the UK Water Report. Thank you for your support. It is very much appreciated. And also, thanks to our two sponsors from last night. I certainly enjoyed a very good dinner. So thank you to Horizon Water Infrastructure, who sponsored the dinner, and also to Tetra Tech RPS, who sponsored our pre-dinner drinks reception. Do make sure that you catch up with the exhibitors and sponsors during the breaks today. Right, in terms of housekeeping, please ensure your phones are off. Fire alarms, again, like yesterday, we're not expecting any fire practices or anything, so if it goes off, it's real, and we need to leave the room by the exits indicated. Q&A, you've got two ways of doing this. You can ask on Slido, or if you're feeling brave, you can put your hand up at the right point, and we'll pick up your question from there. We also have some Slido polls going to run through the day. There's one live at the moment, which is the one that was briefly mentioned yesterday, the poll on whether we can get to 50% leakage reduction by 2050. Well, I think we're about 70 at the moment, so it'd be great if we can get that up to at least 100, and we'll come back with a conclusion on that later. And today is obviously our last day, so please don't forget the feedback form. You should have got one of these when you checked in with your agenda. You may want to complete that as you go along today rather than leaving it to the last minute. Or if you prefer to do it online, you can scan the QR code and do that. And I know that Judith and the team really appreciate your feedback, so please do that. Right, now let's start today's proceedings. So as I mentioned, we've got the Repair Amend Forum. And today this is being opened by a presentation from Tim Evans, who's the lead Water Network Scientist for Research, Development and Innovation at Thames Water. And Tim is joining us virtually from Thames and is going to provide insights into an OFFOR Innovation Fund project, No Dig Leak Repair from Concept to Reality. So welcome, Tim.
Good morning, all. Hope you had a good night on the tiles and you're all bright-eyed and bushy-tailed this morning. So I'm going to be talking about an OFFOR innovation project that has just kicked off called No Dig Leak Repair from Concept to Reality. So if you move on to the next slide, please. So I have to do this Chris Whitty style, I'm afraid. Going to be covering very briefly the traditional leak repair process that we all know and love. Why we're interested in no-dig leak repairs and what we mean by them, the journey we've been through to kicking off this project, and then going into some of the technical requirements and the technology concept that we're looking at, and finishing with some project headlines. Moving on, the project is not looking to do anything at all about the detection process. So the process as is would be the process that we would be using. So I don't want to focus on that in detail, but just to emphasize that that process will typically end with blue paint on the road, marking up a 1 meter square, and that's about as well as we can know the location of the leak before we dig. And that excavation might need to be extended. It's not guaranteed to be within that 1 meter. So next slide. So the leak repair process that we're currently all using is essentially quite a protracted process. Some of us are more efficient than others at getting from one end to the other, but it's quite an onerous process. I'm not talking about emergency digs here. I'm not talking about burst mains. This is all about hidden leakage. So you've got planning, lots of planning steps involved, liaison with the higher authority, scheduling resource, and that this process might be days, it might be weeks. And then when you get to site, you've got to set up the site, traffic management, do your buried utility tracing, and then you've probably got somebody else coming to do the repair, to excavate and pump out. You might need to have some technicians available to throttle the main or even isolate it. And then you get onto the actual repair itself. And once you've done that, then probably you've got a different team who come along and backfill, possibly someone else again to do reinstatement. And then you've got to clear the site. So that's quite a protracted process. So moving on, the reasons why first of all, just to slide on the actual types of failures we see. So not all of these are likely to be hidden leaks. Some of them are going to be visible. We've got quite a variety of leaks. And the reason I'm showing these is because we're not likely to be able to repair all leaks that we find. So we need to be able to identify which one is which before we try and repair it. And then over on the right, you've got the various different dig repair techniques. Most likely to be some form of clamp or a pipe cutout if it's a more severe failure. So realistically, what we're targeting with this project is external repair clamps. We're not looking at situations where the pipe would otherwise have to be cut out, because the chances are then that the road's been washed away anyway and we have to do a dig. Next slide is talking about some of the key issues with the traditional process. So the cycle time I've already called out. So all the time that we're going from the leak being detected and marked up in the road through to the repair being done is water lost. And there's also the cost of all the different activities that are involved in allowing this process to happen. We know it's a very disruptive process, causing inconvenience to customers and road users. And there's the associated societal cost with that. And then there's damage that could or sometimes does happen to roads and other utilities. So primarily there's the safety risk with utility strikes. And then there's various additional costs that follow as a result of that consequential damage. So those are things that we all, we're trying to find a way of moving away from. Next slide. So why are we interested in no-dig leak repairs? So I've taken out the slide that I would have given on the background to leakage, because this is the leakage conference, so no need to hammer that home. But just to kind of reiterate something that Jeff mentioned in the introduction, and which sounds like JSE talked about yesterday. So on the PALM acronym, we know that there's a lot more been going on historically on awareness and location of leaks, with less attention being given to preventing and mending leaks. So Jeff's already mentioned about mains renewal not being a viable approach, at least in the short term, to delivering the kind of ramp up in leakage reduction that we need. Can we just do more traditional find and fix? Yes, within reason, but as I said, it's very disruptive. So with the diminishing returns we get from fixing smaller and smaller leaks, that disruption becomes less and less proportionate. And we're going to reach a point where that's not credible either. So we think that a repair solution that avoids interruptions to supply and reduces transport disruption markedly could play a key role. So we're kind of seeking a transformational change here, really, to water mains repairs. We're almost kind of skipping a couple of steps ahead and looking at what the ultimate future could be like. And we want to increase the rate of leakage reduction, but also have it happening at lower cost. Next slide. So what are we aiming to achieve? So there's a diagram on the right that's kind of like an illustration of the kind of the principle. We want a technology that is able to enter a water main via an existing asset, probably a fire hydrant. But the point is, we don't want to have to dig to install a new asset. We then want to be able to locate and identify the leak. So if we know that it's the wrong kind of leak to repair, we won't attempt to repair. There's no point. We also need to be able to pinpoint it more accurately than the kind of plus or minus 1 meter, because a repair needs to be in exactly the right place. And then we obviously want to be able to carry out the repair and test that it's been successful. And throughout all this, we want, as I said, no excavations. So not just keyhole excavations, but no excavations. Nothing wrong with keyhole excavations. I'm all for it. but this is kind of perhaps a more ambitious project than that. We don't want to cause any supply interruptions to customers, and we want to minimise transport disruption. And we want this whole process to be completed faster than dig repairs. So not only the time on site, but also the lead time between detection and arrival on site. And it has to be competitive on things like cost and health and safety and carbon, otherwise it's not going to get adopted. And when I was just kind of checking everything I had in these slides, I realised I've missed out water quality. So in the editing process, I've removed what is the single most important requirement that we've got to fulfil, which is it has to be Reg 31 compliant and not cause any deterioration of water supply to customers. So overall, the goal is to move from where we are now, where we've got lots of potential technologies that aren't yet integrated, to having a prototype no-dig leak repair solution that will be viable for future commercialization. Next slide. So the journey we've been on, I left this in because I thought this would be potentially of interest, because we have been on a journey. So we started off thinking that this could be a challenge-led project. And we went to the Ofwat Innovation Fund saying, please can we have some money? We don't know who we're going to work with, but we've got a great idea for a project. And they said, seems a bit risky. We're not convinced about it. So we went away and did some more work, did a technology review, got some funding from Transport for London and improved the submission. And that still didn't cut the mustard with the Ofwat Innovation Fund. So we went away and had to think about it, spoke to Ofwat about it. We realised that the uncertainty of a challenge-led project wasn't going to get past the fund as it was then laid out. So we decided to kind of progress with the first stages of the project ourselves and then go back later. So we went to the Northumbria Innovation Festival in 22, engaged with the supply chain and the industry, and improved our technical requirements. And that helped garner the interest for our sourcing process, where we had 6 bidders for a formal tendering process. And we selected 2 to carry out a concept development that we funded ourselves. And that yielded 2 very credible project plans, from which we chose the one from Synthetech and their partners, ALH Systems and WRC. So when we went to the Ofwat Innovation Fund again last year at Breakthrough Challenge 4, the project was clearly a lot better developed, a lot lower risk than it had been, and we were awarded the funding. Okay, next slide. So the project is all built around what we call baseline technical requirements, which is a list of capabilities that we think the technology will need. There are 29 of them currently, but it's a live document. And we kind of set 3 different levels of attainment, minimum, desirable, and preferred. And we're aiming to achieve against the minimum in all cases, but as far as possible, we want to exceed that. But we appreciate that there will be some trade-offs between different requirements. And I just pulled out a few examples there. So the first one I've got in the blue in the middle is the impact to customer water supply. And obviously, ideally, we prefer there to be no impact at all. But as a minimum, we need to manage interruptions to keep them below 2 hours. The one below that is about the nature of the leak. And obviously, in an ideal world, we'd be able to repair any leak that existed, regardless of material or severity. But at the minimum level, we know that repairing a 15 millimeter pinhole or a joint leak is not only going to be the most technologically feasible, but it also represents a significant proportion of the repairs that will be carried out. And then at the bottom there, we've got the insertion asset. And ideally, we want to be able to go through any hydrant that any water company has got in the UK. But as a minimum, we think that it ought to go through a through-bore hydrant because those do exist and they are increasingly being rolled out. And that provides an 80 mil opening, provided you take off the outlet first. Next slide. So this is a concept diagram that Synthetech worked up as part of their proposal. It's only really just to kind of give a flavour of what the process would look like. The subsystems that are depicted here are not necessarily the ones that will end up being used. It's just an illustration. So it's showing on the picture on the right a device that in this case is tethered, going in through a hydrant and travelling down the pipe. and then is getting to where it finds the leak. It then inflates some stoppers to isolate the leak between two plugs, and then it's doing its repair process, the preparation and the sealing within those two stoppers before being removed. So those are just kind of ideas, really. It's definitely not the case that we're talking about this being a spray lining solution. This is definitely a localized repair, but spraying a sealant on is one of the possibilities. Next slide. So this looks like kind of just a whole load of blocks with writing in. I'm not expecting you to read it all, but I do want to kind of signpost the sexy name that Synthetech gave it, which is a subsystem technology stack, which I think is a lovely way of describing a list of options. So each of those headings along the middle is a different requirement that we want the technology to be able to fulfill. And then each of the boxes below that are possible ways of fulfilling that requirement. So the ones in blue are the ones that are already in use. Green would need a bit of development. And as you move through yellow and into kind of amber red, those are things that are less credible. So Synthetech have got lots of ideas for things to work through to decide which of the individual subsystems are going to be most suitable for integrating into a final product. Next slide, please. So just to summarise then, the project is a £6.7 million project that we've just kicked off. It'll be running till January 2029. We are leading it as Thames Water with Synthetech and ALH and WRC delivering it. We've got funding from Dŵr Cymru Welsh Water, Southern Water and Transport for London, and we've got a whole load of other water companies who are providing the kind of the breadth and the oversight to ensure this is an industry-wide suitable solution. We certainly don't want this to be a Thames Water solution because that's not going to have the scale that we want it to achieve. Project phases, so there are 4 development phases, each aligned with the TRLs that we're aiming to go through, and we're going to be aiming to finish up with field trials, where we've done a full field trial under live conditions of the prototype system. And phase 5 is actually kind of a thread that goes throughout. We all know that knowledge transfer is an important part of these projects. We think it's going to be an absolutely crucial part of this project because the project ends with a prototype being demonstrated. It doesn't end with commercialization. So we want this project to not only help Synthetech move towards commercial use of this type of technology, we also want the rest of the supply chain to be taking interest and picking it up, maybe doing different materials than we're looking at, maybe throwing in different ideas for how to do different aspects of it. And Synthetech are here today at their stand, as is my colleague Faraday Hamilton. So feel free to go and talk to them about any ideas you've got afterwards. And just to highlight that we think there are quite a lot of synergies with other Ofwat Innovation Fund projects. So you'd have heard about these yesterday, I think. And we think that the National Leakage Research and Test Centre will be a great opportunity for doing the trials. Yorkshire Water's Design Aligner project is a similar type of technology development project. So we think there's things that we can learn from that project. And then Jez has given you an update yesterday on the universal access point for water. And obviously, if we have an easier access point to use than hydrant, fantastic. And so we'll be looking to learn from all those projects. So that was my last slide. So I think we've got hopefully time for a few questions.
Right, we have indeed got some time for some questions. So who wants to go first? Anyone? Anyone? I haven't got any online. Right, well, I'll ask one to start with then, and you can have a think. So Tim, thanks for that. I mean, it's a really ambitious project, really exciting. Have you got any particular thoughts on the types of pipes or types of leaks that you're targeting here, or do you think it could be applicable in any situation?
So I didn't go through the baseline technical requirements in detail because no one wants 29 points of technical detail listed out to them. But one of the ones that I didn't mention was the pipe material. And just like the leak type, we know we're going to have to target pipe materials that are going to be the best opportunity for the technology. So we're targeting ferrous pipes as being the minimum. And it might be that the nature of the repair will also make it suitable for other materials as well. So that we'll always bear in mind throughout the project whether the capability can be expanded to broader situations. But in the first instance, we're targeting cast and ductile iron and steel, and we think that small non-structural leaks in all of those could be repaired using essentially the same solution, whatever that solution turns out to be. It could be some kind of mechanical seal, it could be some kind of curing sealant, it could be something along the lines of Aqua-P or Origin, where you're causing something to flow into the hole. So we don't want to reinvent every single aspect of the technologies. We want to be able to use things that are out there as far as possible, and show the kind of the industry and the supply chain the art of the possible, and make as much of that available under the terms of the Ofwat Innovation Fund's IP requirements as possible.
Yeah, brilliant. Thanks. Thank you, Tim. Right, any questions from the audience? Yes, we've got one. Jez, I think. Can you wait for the microphone, Jez? Is that all right?
It's Jez. Thanks for that. Really, really interesting. You've picked probably one of the most challenging environments to kick that off here in terms of London, in terms of distribution systems as well. So you've got small diameter mains, really dense urban environment. How do you feel this is going to cope with going into those environments as opposed to the large diameter stuff that we've traditionally kind of inserted into? You talked about water quality. That to me is a deep concern as you're going down and the potential to stir up sediment and things like that as you go through. What's your thinking on that?
So your first point on the kind of the diameters and the types of mains that we're targeting. You're right that large diameter mains are going to be a bit easier to do a repair in. You're not going to have to miniaturize your robot so much. But the opportunities for doing those repairs will be fewer. And we want to have something that is going to have benefit of scale in terms of number of jobs that we can convert to this type of process. We've looked before at a kind of high value repairs on trunk mains, and it's harder to make the business case for that on the basis that there aren't quite so many of those repairs done. So we think the opportunities on smaller mains will be greater in number, and that will be an important part of the use case. Small mains also are closer in size to the sorts of entry points that are going to be readily available. So even if there is a universal access point, it's likely to be rather smaller than the diameter of trunk main. So we think that one of the biggest parts of the challenges will be getting a miniaturized device to go in through a hydrant branch and into the main. And almost once you've done that, then being in the main is no more challenging. So almost if you had a miniature robot that had to go through a hydrant and then expand to work in a much larger pipe, that might be even more of a challenge than developing something for a small pipe. And in terms of water quality, absolutely. So we know that projects live and die by their effect on water quality. So the Torco project that Yorkshire led with government funding, one of the big challenges for that was the effect of Torco is fibre in water, putting a fibre optic cable into a water main for telecoms and for leak detection purposes. And one of the big problems with that was the effect of having a device, having a duct inside the main, and the effect on water quality, sediment, and damaging tuberculation. So we know that this is going to be one of the biggest challenges. And so fundamentally, if we can't find something that's going to enable that to be done in a way that doesn't detriment water quality, that will be a reason to stop the project early. Yeah, the project is not worth spending £6 million of customers' money on a project where we know within the first year that we're not going to be able to cope with one of the key challenges. So at each stage of the project, we're going to have to be assessing very critically whether we think that we're at a point where it's worth proceeding. And water quality is absolutely one of those key aspects. We know that we can already go in through hydrants and do work with small camera systems, and the challenge is doing that with something bigger and more complicated.
Brilliant. Great, thank you, Tim. And just one, could I have a really brief answer to this if possible, but we've got one question online. Are there any existing no-dig solutions available in the oil and gas industry that could be adapted for the water industry? So have you got any quick thoughts on that before we move on?
Yes, well, Synthetech have already developed one for the gas industry, so great partners to be working with. They have a device that will spray a sealant onto a leaking joint seal. But that has to be done in a water-free environment, and the sealant wouldn't be Reg 31 approved. So there's plenty of opportunity for technology transfer in this project, but water quality is one of the biggest hurdles.
Yeah, absolutely. Brilliant. Yeah, thank you, Tim, and yeah, thanks for your insights this morning. Right, now I'd like to welcome Alex Bivey, Project Manager, Yorkshire Water, and also Chair of the Expert In Situ Lining Group. And Alex is going to introduce us to in situ lining being undertaken at Yorkshire Water. So, Alex, over to you.
Right, can you all hear me all right so far? Right, brilliant. So, hello everybody, good morning. I'm Alex Bivey, I'm the Project Manager at Yorkshire Water and the Chair of the Expert In Situ Lining Group. So I'm here to talk to you about in situ lining at Yorkshire Water at the moment, and we're doing something called semi-structural in situ lining. There's a lot of hyphenated words in there, but yeah, in a nutshell, semi-structural lining is the rejuvenation of existing assets and networks that we've currently got in the ground at the moment. So we tend to clean the existing pipe, and from there then we'll apply a spray coating into that existing network and hopefully rejuvenate the lifespan of that asset. So I'm just going to give you a bit of an overview of the programme of works that I've just currently had on at the moment. So current overview, so it was promoted from service delivery. There was 6 worst performing DMAs in the area of Yorkshire that were promoted for mains renewal / replacement. The 3 DMAs that were in this programme were identified for semi-structural spray lining due to water quality issues and also the water quality issues, also mains failures as well, but also with the time and cost constraints that we did have with that area as well. So yeah, the objective was to renew over 3 DMAs, 9 kilometres of clean water main using the 320 Resiline product. So this Resiline 320 product is Reg 31 approved from the DWI, and it also has an assurance lifespan of 50 years as well. Once applied into that water pipe, it's all correctly applied, which it should be every time, which is good. The main diameters that are targeted do span between 3-inch and 12-inch throughout this lining programme. So yeah, the wider range meant that there were different thicknesses that are applied. So the specification for this 320 application from 3-inch is a minimum of 3mm application post-cleaning. And obviously when we got to the 12-inch, there was a greater thickness that had to be applied on that main also. So I'm just going to go into a bit of a day in the life at Yorkshire Water and where we tend to start off and what each step goes through on that process within that day. So the start off is the cleaning of the water main. So just to mention, this is all done within the isolation period of 3 hours. So the live water main is isolated, cut out, and we go from fitting to fitting. So if there's 2 valves either side, they'll be exposed, removed, and then we use those 2 as the reception pits for the lining. So that'll usually span over about 100 metres depending on the size of the water main and also the condition as well, pre-investigation works that we've already done on that section of main. So the first part is we use a cleaning method called Vortex by Air, which is the whirlwind which Morrison Water Services use at this moment in time. So the ins and outs of it is we use air to blow through a vortex within the water pipe, and it'll go from one side into the reception side. And also, if we are using something where there's high incrustation in that area in the water main, we also use flint or red double-washed aggregate as well, and that'll be there just to remove any incrustation on that water main that's within there. So like I said, it's high volume, high velocity, but with low pressurised air that's going into that system. And the good thing about this as well, it does go around bends, so it's been a big win for us using this system throughout the whole of the programme. And also it does produce warm air, which helps to dry the pipe along the side of us cleaning it as well, which is really good. So I'm just going to show you a diagram of what it tends to look like on the site. So you've got your aggregate pots and your blower unit with a connection pipe from one side of your water main. Vortex of air or stone that goes through there to clean that pipe, and then it'll go back into another connection pipe, and an aggregate catcher will take that in there. So yeah, we look to use 3 to 8 inch diameter mains for this method. We also use drag scraping for anything above 8 inch. And also with that, like I said, it cleans and dries it within an hour as well, which is a big win for us on the isolation period. So just in terms of the lining itself, so a lot of this presentation is just images of live sites. So this is one at West Bar Green that we've just been carrying out. So the first part of the lining process is the weight checks. So on the lining rig that's just behind the tractor at the moment, that's where all the magic happens in effect. So the hoses, the paint is all weighed and measured out in this area. So we have to carry out 3 weight checks on the lining material to make sure that it's to the right mix ratio for the correct application. So that is done at the preliminary stage, and also the tanks are always warmed up to their optimal temperature to ensure that the material is cured and set at the right temperature. After that, you pull your hoses through after your cleaning, put the lining head to the first reception pit at the other side of the job, and you'll carry out a spin up. And at that point is where you're making sure all your paint's all mixed together correctly. And then you will take your dip cards pre-lining. So the dip cards are taken to ensure that the mixture of the paint is in the correct thickness, the tactility is fantastic, and also to make sure that there's no other concerns that can be raised from a visual look at that dip card. Once you've done 3 of those dip cards at 10-second intervals, you'll then begin with the lining. So the lining you commence by putting the lining head within the pipe, and then the lining rig's got a controlled flow meter unit that will pull the lining hose back throughout the main at a constant flow throughout that pipe. So that's all controlled electronically, and if there is any issues with the flow or anything that's been inputted into the rig, there is tolerance limits. So with the flow rate, if it goes plus or minus 10% of that of the flow that's in there or the thickness that's applied, an alarm will raise, and that will shut off the rig, and that section will be abandoned if it's not deemed suitable for the criteria that we need to meet to agree that. So yeah, that's just a little bit at the start of the project of the lining section, and then from here, then your lining will go all the way through, and you'll get to the other side of the job, which is near where the lining rig is, and you'll take your exit dip cards from there as well, just to ensure that you've had a continuous lining mix. And as you can see at the bottom image there, that's the dip cards that are taken. Once that's done, it's a fast setting material, so it does take 2 minutes to cure, but the manufacturer's approved guidance is that it's an hour total cure for that paint. So after we've got the lining head out of there, we can CCTV the water main from 15 minutes. Once that's done, we will go in and have a look and make sure that all the lining is uniform and there's no misses or misjoints, anything like that could cause a potential defect, and a re-investigation into that, and a dig out and remove, and also checking for any ferrule blockages as well. So yeah, the 2 pictures at the top, we've got the lining skids. So the top right is what we use for the 3-inch work that we did in York. So yeah, it's a bit of innovation. It's a 3D carbon printed skid. So this gives us a lot of benefit on the 3-inch schemes, because we've had a lot of issues historically with bends in this area, and this removed that massively. So it was a really good success story. And then anything above 3 inches, yeah, with the more traditional skid that we've got there, so that's anything above 3 inch. From the CCTV then, once the hour cure is complete, we will then go into the chlorination unit. So the Whirlwind has its own chlorination bowser, which puts 1,000 parts per million and sprays that into the new line pipe. From there, then the main will then be flushed and be back into commission, all within the 2 hours and 59-minute isolation period. So these are just a bit of an image for you guys to see. So the top is from the works at West Bar Green, so that's on an asbestos cement pipe. So for obvious reasons, we weren't putting any flint or aggregate down on this one because we didn't want to expose any fibres. So with this one, it was just mainly air that we put down just to dry the pipe. And on the right is the lining once carried out. The bottom left is the 3-inch cast iron that was being worked on at Chestnut Avenue in Stockton Lane at York. And like I said before, historically 3 inch has always been a bit of a hindrance for us guys trying to line. So yeah, the use of these the skids and also the whirlwind and the vortex by air using the flint and aggregate has provided a lot of benefit in this area. So it's been fantastic. In terms of, so for quality control audit purposes, we do have the 7 different remits that we've got on there. So after every lining that's carried out, we need to make sure that the CCTV cleanings documentation is there in the video, CCTV lining, a CCTV report, a quality assurance document is carried out, dip cards are still saved, the rig printout from the rig itself should be in place, and a non-conformance record. So if there is any defects at all, it is noted, and that there's mitigation method processes that have been put in place. So this is all done electronically now, other than the rig printout and the dip cards, which are still, images are taken and stored on an internal share drive. So yeah, we've got quite a lot of cameras and videos of clean pipes and line pipes at the minute. So yeah, there's a lot going on in there. In terms of the outcomes, so yeah, the 9 kilometres have now all been lined and successfully renewed using that semi-structural lining method. West Bar Green is beneficially complete with final sections of open cut being carried out on Fulwood and Stockton Lane. In terms of a cost saving, so just for West Bar Green alone, we did have a £560,000 saving using semi-structural lining compared to traditional methods. And then also the semi-structural lining also outlined a 40% carbon expenditure saving in comparison to the works being delivered by traditional methods. Like as I said, it's just 2 excavations instead of a long trench with the traditional methods. So there's been masses and masses of savings in that respect. In terms of the key learnings from the lining process, I'd say the big one is the cleaning time. It's something that needs to be worked on because I think within the process of cleaning your pipe into your final lining, your commissioning, your flushing out for samples, you've probably got on a good day, it's a 10-minute window period if your cleaning goes well. So it's it's something that we are actively looking at the minute. We're speaking with suppliers, manufacturers about getting that cleaning time down. But 2 good success stories were the methods used for preparing ferrules before lining. So on site we called it ferrule sucking. So in effect it's putting a cap end on the back of the main, charging some air through with the whirlwind and just opening and closing the ferrules just to get any sediment or material that might have gone in there from the cleaning process originally out of the system. And that was a massive success because at the start of the project we had a 45% blockage rate in the first couple of months. After adopting this method, we got it down to 4% by the end of the whole programme. And then also using the 3D carbon lining skids as well for the 3-inch hose pipes. Like I said, there's been ongoing issues in the past with 3-inch cast iron, and using the acute, these bends that we've been able to line around the acute bends, it's been a really big win for us, and it's improved the meterage that we've been outputting on a weekly basis. So that's everything from me, and I'm sure there will be questions, so thank you very much.
Brilliant, Alex. Thank you. Thanks for stepping in at a fairly late minute as well to do the presentation. It was really interesting. We've actually got quite a few questions coming in online, so I'll tackle a few of those first. Right, the first one is when would you reline a main and when would you renew a main? So what's the sort of difference between your thinking there?
So it'll all depend on the... Is it on now? Can you hear me? Yeah, you got me up. That's fine. So it'll all depend on the mains condition. So we do some pre-investigation work. So we'll take coupon samples of those mains. So if we see that the condition is way too encrusted for lining or cleaning to be carried out, that's when the decision will be made for the main to be renewed instead of replaced. But it just depends on external and internal condition as well of that.
Yeah, brilliant. I know it may be too early days, but have you seen a leakage reduction in the DMAs that have been relined?
we're looking at the data at the moment. And like I said, it's pretty fresh at the moment, so we are trying to give it a little bit of time. But yeah, we will be looking at that in the near future to get the data out there, definitely.
Yeah, that's great. And how thick is the lining? Does it result in the main having a smaller diameter once you've done the inset?
Not in effect, no, because if you look at the cast iron, for example, because the incrustation that we've seen to see within the cleaning of that, we are getting the cleaning is restoring, in effect, the hose pipe back to its existing condition, its pre-installation condition. So from there, the 3mm application that we are putting on that, it's a massive improvement in relation to what the incrustation would have been in that pipe previously. So yeah, it's the 3mm thickness is the minimum that we put on any water main. So yeah, there's definitely a benefit in there.
Yeah, that's really interesting. So you maintain the same diameter just by getting rid of it.
Yeah, definitely.
Okay. And then for AC mains, do you filter the exhaust air, bearing in mind, I suppose, the asbestos risk?
Yeah, we will do. Yeah, like I said, it's we never put any aggregate or flint down for that point, just because of obviously the contamination and the fibres that we would expose at that point. So it's always the warm air that's dried out, and that's always contained and filtered away. Yeah,
brilliant. One that I also was thinking about when I was listening to you talk was the customer kind of reaction to it, because this is obviously different to digging up the road, but you've got kit there and you're still doing a process. Well, what's the kind of feedback been, if you've had any?
Well, I'll be honest, from comparing it to traditional methods, so for a customer, if you're doing 100 metres of open cut in that section, they might see us there for 2-3 weeks, whereas with this lining method that we are using, we could do 100 metres a day. So for that day's disruption, in comparison to 3 weeks, it's a big win. So the customers seem very satisfied with the works that are carried on, and they always are quite intrigued to see what's going on when they see a tractor turn up when we're doing construction work. So yeah, it's been a good win for customer benefit, definitely.
Oh, that's really good. Right, we'll do a couple more. It's like any question.
Yeah,
it sparked a lot of interest. What frequency is there of ferrule blockage, would you say?
So, like I said, at the beginning, it was about a 45% blockage rate that we had, and that was just down to using the 3-inch with the application of the 3mm that we were putting onto that lining at the time. It was just causing more and more issues. So, yeah, like I said, we've got that down now to 4% just by working on different methods at that time. So the ferrule sucking has been a massive game changer for us in that way. So, yeah, it's reduced significantly. I think on the first street that we did, out of 10 properties, I'd say, 5 or 6 might have been blocked to start off with, whereas now we've done the exact same, and we've had one probably every 30 properties at the minute. So it's been a really big win for us with the ferrule sucking.
Yeah, brilliant. Good. Any questions from the floor before I take one more from here? No, you've all asked on Slido. I like this. Good. Okay. Final question then, Alex. Does lining count towards mains renewal targets?
I believe it does, yes, at the moment. We're just waiting to see with the determination as well now, so if the viability will be there for the lining. So that's why I've come in front of you guys today to promote and push as much lining as we can do, because I think with the meterage that we have to achieve going into AMP8, I think traditional methods and other innovations might not be the only thing that we can do, and I think lining will push that on to get us to where the targets need to be as well.
Brilliant. Yeah. Great. Well, please join me in thanking Alex, not just for a great presentation, but for questions as well.
Thank you very much. Cheers.
Yeah. Good stuff. Right. So next up, we've actually got a group presentation on managing real-time repairs with AI. So something that's slightly different. So I'd like to welcome Karen Atkinson, who's the manager of leakage reduction at Yorkshire Water, Stephen Jenkins, who's Senior Operations Manager at Morrison's Water Services, and Joe Mitchell, who's the Account Director at Field. So over to you.
Good morning, everyone. I'm Joe Mitchell. I'm an account director here at Field, so I work closely with our partners in the water sector. Thank you to Karen and Steve for joining me this morning. It seems rite of passage to mention how long that you've been coming to this conference. It's our first year here as a business, so thank you for the opportunity to let us talk to you about some of the work that we've been doing with our partners. As a newcomer, luckily I wasn't dragged into Birmingham city centre last night, so I appreciate the experienced heads not leading me down that path. But yeah, I think, first of all, talking to you about what it is that we've been affecting in the leakage space. It's interesting for us. We're a business that's been running for 3 years now. I don't confess to be an expert in leakage, however, I'm learning quite quickly. But certainly the work that we're going to talk you through today is really how our tool is connecting all the stakeholders when it comes to more the repair side of leaks. So the reality is at the moment, obviously that traditional method's still being used where you need boots on the ground to go and repair those leaks. And how is our tool impacting that space? So just to strip it back, what is Field? Well, Field is an end-to-end execution of work tool that focuses on that repair element. We connect field workers and managers in real time. That in turn can lead to contractor management, so the use case that Steve and Karen will dive into in a bit more detail, where you have that ability to manage your supply chain. And then ultimately that data that we collect from the ground, what are the kind of actionable insights that we can provide? So it sounds quite shiny and new. To strip it back even more, how does that look in terms of day-to-day operations? So we have a mobile application that is used by leakage inspectors, by R&M gangs, and the way that they collect data is slightly different to what you see in the market at present. So everything that is collected is video-led, and then we use AI to analyze those videos and summarize that information to managers in real time. So certainly connecting Yorkshire Morrisons has been interesting in that space where you can have real-time visibility of all of those repairs on the network and what are the kind of efficiencies that you can gain in terms of driving speed into actually getting those leaks delivered in a quicker amount of time. So our solution, to give you some context, Morrison Water Services were using Field before they actually took it to the client Yorkshire. They use it for their R&M work, so that could be everything from capturing your risk assessment at the beginning of the day to actually evidencing how you've set the site up, all the way through to videoing the actual asset on exposure, on repair, and then at the end of the day, leaving a video to show the condition of how site has also been left. Now, what became interesting, and when we started evaluating the process of how leaks are actually promoted from Yorkshire Water to Morrisons, we started to unpack that there was probably quite a lot of blind spots within that that could lead to kind of delays or not getting to that repair and delivering it in the target time that you had. So we approached Yorkshire Water and started talking to them about, well, if we got your leakage inspectors to use our mobile application to take videos of when they've located the leak, when they've marked up, what's the condition around that leak, and in turn, if that is shared with the planning department at Morrisons in real time, what's the actual benefit of that? Well, what we were seeing is that around 20% of the time, prior to using Field, they're having to conduct a site visit because they might not understand, okay, at that location where they've marked up, what are the TM requirements? Does it need to be out of hours? Is it in a customer's driveway? And often that could lead to the need for an additional site visit to be added in order to actually go and understand how you can successfully plan that job and then execute it. Whereas now the process that we've embedded, you've got that Yorkshire Water technician using Field to take a video of the condition of where he's marked up. That planner can view it in real time and then schedule that to be released to operations. So Karen and Steve are going to go into a little bit more detail around what that looks like. I think my own reflection has been fundamentally a real behavior change from the ground. I think often static photo capture and manual data entry can be a bit limited. So I think when you start leveraging the experience of the operatives on the network, asking them to talk through what they see and show you, it's really increased the quality of information that we're getting, and ultimately that information sharing between all the stakeholders within that leaks life cycle in terms of the repair element is what's driving speed and ultimately reducing leak runtime. So I'll hand over to Karen to talk to you about that from a Yorkshire Water perspective.
So I guess this morning we've heard quite a lot about how expensive R&M can be, and we recognise that there's quite a lot of waste in our processes. So we do spend a lot of money on dry hulls. We don't always get it right first time. And the time taken to get a leak from the point that we mark it on the ground to it being repaired can be quite long and protracted. So one of our business plan initiatives this year was to reduce the runtime of leaks. Our processes, though, are quite clunky. So we use SAP to manage our work, and there are a limited number of text characters that we can use in SAP to describe what we're doing, and we used to attach a photograph. But the processes were pretty poorly adhered to, really, and photos weren't really being looked at by the planners. They were using Google Street View to do planning and scheduling. Sometimes a blue mark would wash off. And our leak inspectors felt a little bit disconnected from the process, and they were also struggling sometimes to understand when a leak had been repaired. If the quality wasn't quite there, they'd go back to site, check it, there was still a noise there, and they couldn't really understand what had gone on, because once the job went into the SAP machine, they never saw it again. So what it looks like today, a leak inspector arrives on site, and we actually use the field app for our point of work risk assessments as well as our work promotion photos. I think previously our point of work risk assessments from a leak inspector perspective were probably a little bit of a tick box exercise, and it was a process they had to go through. But if you ask me what kept me awake at night, apart from hitting the leakage target, it would be the safety of my leakage inspectors when they're working in the highway. And now, when they're doing a field risk assessment, when they're doing that video, it's really obvious to capture some of the risks, and therefore they're able to mitigate these risks in a much better way than they were previously. But then when they put a blue mark on the ground, they'll take a really good quality video. And we have had a mixed buy-in. I guess our Snap generation field and leakage inspectors have taken to it perhaps a little bit better. But actually, there's really good engagement, because what they can do, they can tag themselves in the job. So as soon as the gang on site on that job, when they're doing their risk assessment, the leakage inspector gets notifications so they know the gang are there. Our leakage inspectors might take a few days to walk around a DMA, so they might have promoted that leak yesterday, and it might be getting repaired tomorrow, so they might still be around. So they might be able to pop past, they can go back and check, they can check the workmanship, and if they're not happy, they can see the quality, they can see what the gang have done on site and assess whether they got what they asked for. So the other thing, like I said, we don't always get it right. We do have a high proportion of dry holes. I push my leakage inspectors quite hard for promotion, and sometimes, you know, the lower the volume of leak, the harder it can be to pinpoint. So when the gang are on site, the leakage inspector can see a video. So we're working towards a video request for assistance from the gang. So we can ask them to dig further. We can assess whether they've dug what we wanted them to. So it's been a really positive process. The other benefit is we have just seen the life of a leak come down across the patch. So I think the majority of that is to do with the planners just planning more effectively, and everybody, and the end-to-end process just shortening down. And obviously, if we reduce our leak run time, we can promote less leaks.
Okay, so just leading on to the repair aspect, I think the most tangible sort of benefit from use of field that we've seen is the reduction in need for site visits from supervisors pre-repair. Karen touched on leak life before. I think any opportunity to kind of shorten that through optimising processes is obviously greatly appreciated and vastly helps in the leakage arena. Obviously, resourcing, cost efficiency, etc., all optimised throughout that. So in terms of the R&M aspect, so fast-paced environment, as we know, reactive to issues on the network. Obviously difficult to allocate resources and deliver first time. So obviously we all know we're under very strict time constraints. Blind spots from the ground significantly reduced through this. So previous lack of visibility is obviously enhanced vastly throughout the use of field. We're able to highlight the high-risk jobs and anything that could cause delays. Obviously, mitigating factors or mitigations rather put in place to reduce those. And we've seen a big reduction in fines, penalties, and what have you. So increased compliance through the ability to sort of forward plan and see site conditions through use of the app. So in terms of a day in the life of a repair gang, so arriving on site, the guys then take a risk assessment on field, as was mentioned before, giving us a clear view of site conditions, site setup, and then obviously once the repair is undertaken, there's a video taken again then to sort of give us satisfaction that the job's been done as requested. Also gives us a chance to sort of share learning in any instances of dry holes, etc. Any job blockers, so we can raise repair issues with the Yorkshire Water Hub. I think another benefit that we've seen is the ability in some instances to issue instruction to the gang from the hub without the need for a site visit. So can ask the guys to chase the leak, etc. in some instances. And then obviously at the end of the day, wrapping up, share condition of the site conditions on site at the end of the day. So in terms of user feedback and the benefits that we've seen, so quality and resource, so improved collaboration with the client, so again, improved visibility of everything on site and sort of understanding of what's being done. We've got improved work quality through job visibility, better resource utilisation, so again, reduced amount of aborts, reduced amount of job failures and what have you, increasing our effectiveness of the overall resource pool. So speed, mentioned before, leak life on a number of occasions, so a reduction in time consuming site visits, reduction in job delays, and also a change from reactive to proactive operations there. Penalties, like I mentioned before, so a reduction in fines, so evidence against Section 74s and MOPs, etc. And obviously increased street works compliance there. And overall sort of satisfaction and feedback from the ground has been positive. And again, as we enhance the process, I think we'll see that improve even further. So yeah, in terms of the measurables, 300k saved in fines for last year, and an 8% productivity uplift, which I think, from what we said before, we think we'll see that increase even further there. And that's us. Any questions?
Great. Fantastic. Brilliant. And we've got quite a few questions already, so that's good. Right, so yeah, keep asking away. If there's any in the room, I'll come to the room in a minute. So yeah, the first question I've got is, does this replace work management systems? So Karen, can you kind of get rid of SAP completely or not?
No, I don't think we'll ever get rid of SAP. We use it to pay Morrison's. Unfortunately not. We are talking with our tech colleagues about integration with SAP, however, so potentially one-way or two-way integration. So rather than having to use two systems, which our leakage inspectors, field technicians do complain a little bit about having to duplicate effort, we would do it in one place and they'd link together. So that's at the early stages at the moment of conversations, but I think Joe and his tech team are really confident that they could do it if we could do it.
Yeah, brilliant. Yeah, anything to add to it?
Yeah, just to add to that, I think where we see ourselves in terms of where we sit within that solution architecture is being complementary to the current work management systems that there are across the various water companies. So yeah, what is the value of integration? Well, often it's just getting the data out in a cleaner way. I think what we do is that kind of arm that reaches right into the ground and gives you that visibility. So if you have a SAP work order, actually one of the things that we've done is we've got an API that sends the evidence of that work being done, so the asset on exposure and repair, and that goes back to the Yorkshire Water commercial teams. They can validate what Morrison's has done. So if it's a value, then yeah, absolutely, we'll look to integrate with the work management system.
Yeah, brilliant. Yeah, good. Alrighty, and people are getting a hand with the upvoting as well, so it's changing on my screen. But yeah, so the next question, I'm going on the top rated. Could this system, I suppose, as a whole, be integrated with a public-facing system for leak reporting and updating customers on progress in real time? Question there.
Do you want to?
Yeah. Yeah, I mean, I think that there's, endless possibilities in terms of the direction it could take. One of the things that we've actively started to look at is, leaks being reported by customers and how you can capture that information. So we're adding to our current feature suite, which is the ability for customers effectively to receive a link via text message. And then from there, they're able to video actually where the leak is. And in turn, that can be then shared with the client so that they can triage it effectively and understand what they need to go and do to deliver it. In terms of giving customers a real-time, up-to-date view of the progression of fixing the leak, potentially, it might be something that, as AMP8 approaches, if there's value in it. I'm not sure what you think about that.
Yeah, I mean, so you've started using it for our smart meter rollout, haven't you, the Show Me application? So I think it's got lots of opportunities. I would say that customers are more and more demanding these days. I expect an Amazon kind of based service from my water company that I'm not currently getting. So I think Field could have the opportunity to give the customers what they want in terms of that.
Yeah. Put it this way, my father-in-law, the water got turned off at our property the other day, and he was saying, "What's going on?
Yeah.
Can you show me on the app what's happening?" So I think there is that demand there.
Yeah. I like the analogy. Good. Okay, quick one. Does the mobile application work offline in areas of poor signal?
It does, yes. It's one of the things we flagged early on within the development. So definitely regions in the UK where the signal is quite poor. We work with the likes of Southern Water, so on the Isle of Wight and places we've run into those challenges. So we have an offline functionality which allows a user to capture videos and do what they need to uninterrupted. And then when they hit a good area of signal, that will simply upload that data that they've captured. What we try to do is also give a kind of real-time view of when that was, so it'll timestamp and date it from when you initially actually captured that data in-app rather than when you hit the good signal area. So we're quite stringent on that. You have to have a certain level of signal to operate online because the AI analysis can be conducted. But if you don't have that, then we'll switch you into offline, so there's no sort of spinning wheel of doom, as it were.
Yeah, very frustrating that would be, yeah. Great. Karen, have you calculated the MLD benefit of reducing the leakage runs by 35%?
You have, haven't you? I can't remember what the number is, though. Where's Kathy? Is she gone?
We have, yes. I mean, so how we trialled it initially was earlier in the year over a 3-month period. So what we looked at was in 3 key kind of patches, which was Bradford, Sheffield and Leeds. And we effectively evaluated the jobs that went through this redesign process and then jobs that didn't, and then compared the two. So that's how we got our reduction in leak runtime. In terms of quantifying the actual pound value of that, from the data we saw it was around a 2 megalitre a day reduction. So industry standard could be in and around just shy of £2 million if you were to look at it. So something that we'll keep kind of doing with Karen and the team.
Yeah, brilliant. Okay. Right, I'm just going to have a quick look around the room to see if we've got questions. No? Right, I'm going back online then. Is there one? Sorry, have I missed one? Yeah. Brilliant. Yeah, can we get a mic out? So, gentleman on the second table back.
Hi, Mike Hurley, Tetra Tech RPS. With all the data you've got of the pre and the post repair, are you doing analysis with that?
Yeah, I think the data piece is becoming more interesting as our partnership matures. I think one of the things that we're starting to unpick more so at the present is understanding what the kind of operational delays are and why teams are getting blocked on site and how we can resolve that in a quicker amount of time. So as Steve mentioned, if a gang turns up from Morrison's and they have an issue on site, they'll use the application to raise a request for assistance with the Yorkshire Water Hub. So at present, we're actually working through some of that data and starting to understand, okay, from this, we can understand the amount of time that the team was delayed. What is the reason? How can you interrogate them more? And how can you kind of set yourself up for success in that? But even things like understanding in certain areas, how can we see that certain teams are being more productive just in terms of their job completion time? So from the point it was actually released by the Yorkshire Water technician to the last pair of boots from Morrison's on site, and what are the kind of best practices that you can see within the actual jobs there, and how does the data validate that? How can you share that amongst other groups on the network, so in different regions, to make sure that you're kind of embedding that quality?
From a Yorkshire Water perspective, we review every burst main that we have and we watch the video. Obviously, the mains repair performance commitment is a costly one if you're over. So if that leak is on a comm pipe or something like that, but it's been promoted as a burst main, you don't want to be reporting it as a burst main. So we review the footage of every single burst main that we have to ensure that it is actually a burst main and therefore reportable. You know, so I think it's, was it £5,000 for every burst main over the performance commitment dead band. So, you know, we do that as standard. We used to do it with photos. Now we do it with the videos. It's a little bit easier. I guess what we're not doing at the moment is linking up with the mains failure database or understanding failure modes and things like that, which is probably an opportunity for the future.
Brilliant. Good. We'll have one more question from Joe, and then we're going to wrap up. Joe.
Joe Sanders, Tetra Tech RPS. Have you seen, Steve, any reduction in utility strikes? Again, sort of like you talked about a lot about the sort of the street work side of things. Obviously, utility strikes are possibly more costly,
Absolutely,
more
yeah.
impactful.
Absolutely, yeah. I think performance overall has improved in that space. I think in terms of the measurables on the back of the field, I think pre me joining, I think there was kind of some data collated on that. Was there, in terms of what you've?
Yeah, I think especially, you know, across not just the framework that Morrison's has for Yorkshire, but for Thames Water and metering, right, in, you know, the London area. I think what we're placing a lot of emphasis on is when the gang is doing those kind of, you know, pre-dig checks, that you want managers to interact and intervene in as short amount of time as possible. So when that video comes through, you know, evaluating, have they clipped the cat and Jenny onto the lamppost, are they marking up, and kind of having that real-time interaction with the gang has seen, you know, I think roughly around 15 to 20% reduction in cable strikes. That's across the board for Morrison's, but yeah, certainly in areas like that, high emphasis on getting that right.
I believe Morrison's went for the whole of November. Was it November without a utility strike? And obviously, you know, we dig a lot of holes in Yorkshire, and so I think that was a big achievement of late. It might have been October, not November, but yeah, we've done a whole month recently without a utility strike, which is an excellent achievement.
Brilliant. Good.
Thank you.
Great. Well, thanks, Joe, Karen, and Stephen. Yeah. Thank you very much. Yeah. Yeah, really good example of sort of technology working for us, but also I love the partnership approach there as well. So good. So now I'd like to welcome Tim. Farewell. He's made it up the motorway in time. Well done, Tim. Tim is going to update us on the review of the current status and future potential of the UCWARE National Failure Database. So Tim, over to you.
Wow, wonderful to be here. Oh my goodness. As I was stuck for a very long time on the M1, I was reflecting on the importance of infrastructure and making it work. So I just wanted to say thank you guys, because what you do in your day-to-day work is actually keep water flowing through the pipe and not leaking it out as much as we possibly could. I've seen firsthand what happens when infrastructure goes wrong, and it's great to be here. Okay, we've been working on a project for UCWARE looking at the National Failures Database. Hands up here who knows anything about the NFD, the National Failures Database. A smattering of hands. Wonderful. Hands up who has ever used it in their work. 4, 5, 6, 7 hands. Excellent. Okay, what we're going to start with is a story about the NFD. So this is how the NFD is designed, is that lots of water companies put in their networks, their failures, into the NFD and allow you as a water company to compare the performance of your network with the performance of other companies, anonymized. The problem was, it was actually really hard to get data out of the NFD. And because it was hard to get data out, companies are like, well, is it really worth putting it in? So, over time, contributions to the NFD slowed, if we're honest, and then it was kind of locked away in the back of a cupboard and almost forgotten about. Oh, it's very sad. But there are more problems arising. You know, guys, what this whole conference is about is reducing leakage. This is one of the big questions and the big challenges this industry faces. We've got deteriorating assets. And of course, we need to get to a low-carbon future. All of these things are made harder by climate change. See last year's talk. Okay, so when we're looking at the NFD, we're thinking again, well, how could this help us meet these challenges? So first of all, can we get the data out? What's in it? No one really knows exactly what's in it. What can it tell us now, and how can we make it more accessible to people like you so you can do your jobs better? So in terms of the objectives, I won't bore you with this, but effectively we're looking at what's in it and what we can get out of it. So one of the first stages was actually getting data out of the NFD so we could do interesting things with it. And now we've got the data out, and it's wonderful, and we can look. So here we're just looking at bursts by the different water companies, and for each year, from the 1980s on to 2018. So this is like the longest run of failure database, like I think anywhere in the world. But you can see these different companies, they put in data, and some years they put it in, and some years they don't. So it's a little bit chaotic. And some companies have put in a lot more than others over a longer period of time. And we've got data both on bursts, but also on sewer failures. And you can see the data on the sewers is perhaps a little bit less complete than on the clean water side. Then we go into the granular detail of looking at actually what data has been uploaded into the NFD. So we can look variable by variable, company by company, how complete that is. And you can see that some data sets are really well populated, like what was the failure or the material sometimes, or the location. And then other things are very much more infrequently uploaded. So we're just looking at building up an idea of how useful this data is. And this is setting us up for what we're trying to do now. And just paint a picture for you of the art of the possible. So my team and I have been working on this art of the possible dashboard where we're giving you an interface, effectively, that you can look at your company's performance. So thank you to Welsh for letting us share their data today, and compare that with the national framework. So what we can do is we can select the company or pipe material that you're looking at. Maybe we're looking at the burst rate, burst per kilometer of pipe, or the actual length. And you can fiddle around with time sliders to say how performance is changing through time. So here, rather than rate of failure, we're looking at the length of pipe, and we're looking at where the PVC pipes are within the Welsh network. So of course, this isn't a fully fledged GIS system, but what it is, it's a tool where you can look at issues in a kind of spatial way, even if you're not a GIS professional. And you can zoom in and, of course, click on it and pull up lots more information. And really, okay, guys, I'm going to set a scene for you here. As you're looking at these slides, think, how can I use this to reduce leakage? Because I'm going to ask you for your feedback at the end. So we can see where the PVC pipes are, and we can also see where failure rates are the highest. So we have lower failure rates near the coast in this case. Then, because it's all linked up, the map and the underlying data, you can then query the table, sort and filter it to identify those pipe cohorts which are underperforming or performing really, really well. So I'm quite excited about it. I think it's quite cool. The other thing we can do is look at how rate of failure changes through time. So this is 2009 to 2013, or 2014 to 2018. So you get different pockets of the network expressing failures. And we can also zoom out and look at maybe a broader scale of how your network compares with the rest of the country, both in terms of where your pipes are, in terms of different materials, or those rates of failure as well. So as I say, what we're doing here, and bear in mind the inconsistency of the data that was uploaded, right? This isn't like a gorgeously perfect data science tool yet. It's more of a, this is what we could do. But here we're just looking at distribution of iron pipes across the network. Because we've built it as effectively a web-based tool, you can pull up as many different browser windows as you want. So we could compare, in this case, this is aggregating all companies' iron failures together and all companies' PVC failures. And you can see that PVC fails a lot more in the summer and iron in the winter. You could look at, in this case, changing failure patterns through time. And this is for this specific water company, and it's their failure rate between 2004 and 9 and 10 and 18. So you can look at how failure rates might change and the links there with weather conditions and so on. The other thing you could do is compare your failure rate with all other companies. So in this case, it's the companies versus the national expression of bursts on that material type. The other thing we can do is select multiple materials at a time, so you can identify these summer failures in maybe PVC and AC pipes, for instance, and compare those with other similar materials and look at the impact of these hotter and drier summers which are coming on these materials. Okay, there's so many things, I could just keep going on going. But here's just another example of looking at the length of pipe. So in this, I think this is Welsh still, they've got more ductile than the national average, but they have less cast iron. So it's a way of just saying, where are we compared to all other companies who are contributing to this project? I won't focus on this, sewerage. We do the same thing for the sewerage side, so tell your sewerage colleagues about this as well. So what is coming up next? We've got a range of things we're really keen to do. We're just in the early stages of this project, but of course it's me, so I want to include weather variables in there, look at how cold weather, hot weather, dry weather impact on failure rates. And I would love now to hear from you guys about how you could use a tool like this to help you drive down leakage in your area. So what's coming? Data. We're going to focus really on uncovering insights which are in the current NFD, and of course making recommendations for how we can improve this so it actually becomes a tool which you guys use rather than just contribute data to going into the future. So we are going to have a dissemination event in the coming summer, and it would be great to see people from each company there. But for now, what I'd love you to do, anyone who has a smartphone with them and hasn't switched it off, if you don't mind scanning the code, it'll take you to a short form where you can, make one or two suggestions on the kind of features which would be really useful for you in your work if you could get hold of this data and actually use it. All right, that's me done. While you're busy looking at that, love to take any questions that you have.
Yeah, brilliant. Thank you very much, Tim. Great. Right, and we've already got some questions flying in on Slido, so we'll start with them and then we'll come to the room. So, interesting one here. Do you think it should be a regulatory requirement to contribute to the NFD for the good of the industry? What do you think?
I don't know if it's my place to comment on regulation. I think as a data scientist, I'm always super excited when people upload data to these things, particularly if it's in a very clean and consistent format. And of course, one of the challenges with having lots of different companies and their understanding of what constitutes a burst, I think a clear definition on a burst and a clear link between the data that's uploaded and that is reported to Ofwat, very clear and transparent, would be very useful. Yeah. Whether it's mandated, not my place.
Yeah, absolutely. Good. All right. The next question I've got here, have our efforts in pressure management affected a database of information resulting in a potential now wave of failure that we won't be able to predict? So, yeah, this is quite a complicated question, isn't it?
Okay, so how is pressure management
affecting this kind of thing? So I guess it's almost like saying that the database itself is changing. Yeah.
Pressure management is a great tool for many pipe materials. I think this is the way that you guys manage your network as a data scientist. This is the kind of data that I'm the most keen that we capture because we can look at where the pipes are and what they are and when they failed. And it's much harder to get a consistent record of data on what you guys have done to manage the network. And of course, that's really important, almost equally as important as the weather or the soil or other environmental factors, which is my focus. So knowing how you've applied that pressure management, when it started, when it ended, all this is really important. Because of course, if you're really excellent at managing your network through pressure management, that can mute the environmental impact. So I'm super keen on that. And so I think that would be a great recommendation for the new NFD, if this ever comes off, that we come up with a way of capturing what you guys are doing to actually manage, and because you're doing such a good job at actually keeping water flowing, so capture it as data.
Yeah, brilliant. Thank you, Tim. Right, any questions from the floor? Wave. Okay, we've got two. So a lady here and then a lady in red further back. So yeah, I think it's Elizabeth. Is it? Yeah. Got a mic coming now. Yeah. Okay.
Hello, so it's Katrina Flavel from Yorkshire Water. So obviously all of this data has immense value to water companies, but also to the supply chain and various consultancies we work with. What's the engagement look like so far with those groups? And what are the plans for in the future? Because we need to help shape this quite significantly.
Okay, so in the context of this project, it's really just reviewing the NFD, and contributions to that stopped effectively in 2018. So at the moment, there is, in this project, no engagement. However, I echo your sentiments that it's super important.
Yeah, brilliant, good question, yeah. All right, Elizabeth, and then we'll finish.
Liz Bowman, University of Sheffield. Yeah, thanks for this talk. It's music to my ears that you're going to be maybe, hopefully, sorting this out, because I think the information is extraordinarily useful. One thing that I've noticed we've been using the database ourselves in an Acquia-funded project, and I think one of the issues that was pointed out to me was the fact that the failure is not the date of failure, or it's actually the repair date. Is that correct?
It kind of depends on the company, because some companies will upload both the date that it was reported, which isn't probably when it actually failed, and then also when it was repaired. So it really depends on the company. But of course, generally, the burst happened a day or two before it was even reported, unless it was a pretty obvious one.
Time-dependent data, you're actually using basically whatever date that you've got to actually attach it to the season or whatever. We're not talking about things that are going on for weeks, though. We're talking about something that's a matter of a couple of days. Is it between, in general?
Yeah, generally it's between a couple of, it's about a couple of days. Of course,
okay.
There are some bursts which take a lot longer to deal with.
No, that's great. Yeah, no, I think it's fantastic. So go for it.
Thank you.
All right, and I guess you'd like depth added to this as well. Yeah,
and I really like pipe depth.
Yeah.
Put it in there.
You missed this yesterday, but yeah. Okay. No, good. Good. All right. Thank you very much, Tim. Brilliant.
Great.
Okay, so for the final talk in this session, I'd like to welcome Jez Heath, who is Innovation Manager at SES Water, and Jez is going to talk us through collaborative work on repair solutions. Over to you, Jez. Thanks.
Right, so morning. Oh my word, gosh, that was a good night last night. Yes, morning everybody. So what I want to do is I want to go through a little of the collaboration stuff and just where we want to take this in terms of water companies, but the wider industry as well. And it's been really great sitting there this morning and listening to all the work that we're now starting to produce in this area in terms of MEND. We've always said we know this is the area that we're struggling with, still that dearth of projects in this area, but we're now starting to see more and more stuff coming through. And what's been really nice is hearing the interest in the room, the questions coming back, and the kind of insight on what we're trying to understand on this. Certainly, I've seen a renewed focus in this area. The leakage managers, when I've been speaking with you, again and again, MEND is now coming up in conversations, which is brilliant, because previously, I think when we first started talking about this, it was kind of like, that's dealt with by another department, and that's no longer the view within our industry. This is something we've got to get a handle on, something we've got to deal with. Interestingly enough, it's been promoted elsewhere as well, and you're going to be hearing from Spring Accelerator, from Spring, about that and about the work that they're doing as well. So they've been picking up on it as well. But let's be frank, brilliant. All the work that's going on, we are still struggling in doing this. It is still generally another department that's dealing with the repair solutions, and it's the contractor that gets sent out to do that. And I've been talking with various companies on it, and it's still issues in terms of contractual arrangements. How do we pass this work through? How do we incentivize our contractors to repair quickly? And so when we start to look at these kind of things, my first point is going, okay, how do we gather some data? How do we understand what the actual problems are? Because unless we understand those, we're not going to be able to address those. So what I want to be doing is some primary research that kind of looks at that, understanding the root causes of these long-running repairs. So, started doing it with my own company. Got my analysts and went, okay, let's start to have a look at this and go, what goes on with our own repairs, solutions. So you can see it here, a cumulative graph here going up. And what we've done is taken, okay, about 10 days. I want to see, okay, beyond 10 days, why have I got that tail going out? What are the ones that are really causing me issues? And why are those problems? Is it procedural? Is it the arrangements that we got? Really interesting hearing Field and the work that you've been doing there with Yorkshire as well, and understanding about whether you can actually just change how you operate because it's a procedural issue and that will really drop your repair times. Or is it engineering difficulties? Is it the fact that this one is right by a railway? You're not allowed to excavate in that area until you've gone through a whole load of bells and whistles and things like that. So is it actually engineering difficulties? So start to tease that out. Really interestingly, when we started to look at it, one of the areas that we came out and I said, okay, well, just tell me what my kind of repair backlog looks like over every single month. Got this huge, great spike at the end of the summer. And when we looked at that, that was down to a couple of years back when we had the summer breakout. That's still the legacy coming on because we included that data. But you can see that there is still variation as you're going through the months. So what's causing that and what effect is that having on our repair times? Started to drill down as well and said, okay, what about permitting? Whenever we got to dig up the road, we have to take out a permit, but you don't always have to take out a permit depending upon where it is in the highway or not. Does that make a difference? And interesting, when you look at the actual averages there, there's not a huge difference, but you look at the variability and we start to go, okay, if you put a permit in, instantly that gives you a timeline that I've got to operate to. You don't want to lose that permit. So actually we were finding that permitted jobs tend to be done better than unpermitted, even though my unpermitted jobs, these ones, are probably easier to do because they're not in a highway. What about my councils? Now I know that Wessex Water have done some great work looking at the councils and saying, okay, how does different council policy about when we're allowed in there, how does that change my repair times? Looked at 3 county councils in my area and said, okay, what does that do? And again, you can see starting to tease out variations. Now, at the moment, this is only saying, is there a variation? And if I talk to Leon down there and said, do you see a variation in terms of councils? Obviously, you're going to say, yes, absolutely. Jez, you're just telling us what we already know. We know this happens. This is the start. What we need to do is gather our data, tease it out, and start to understand where are the strong, where are the weak correlations. Why is this council better than that council? What makes the difference between those, and how do we encourage those ones that struggle during the process? How do we encourage them to change? This is about entering into dialogue. It's about talking to our contractors and going, why do those permitted jobs work that way? How can we change the contractual arrangements so that we can do these repairs quicker? So, going through the analysis, we need these solutions to be adopted quickly. Okay? It's great to go through all these kind of data sets, but we don't want to be just lost in graphs. The whole idea behind this is to generate change in how we operate. And we have multiple operators in this area. You know, councils, contractors, we've got to deal with Reg 31 and everything else as well, the whole planning regime as well. There's a lot of partners in this. It's not as simple as just going to one contractor, one supplier and saying, let's sort this out. And so what I'm looking at the moment is saying, actually, we need a multidisciplinary approach on this one. So this was talked about last year at this conference, and a phrase was coined, and I'm pretty certain it was Dean. I think, came up with this one. But the idea of actually bringing a group together that looks at repair side. Special Leak Services. Now, I picked that name, or at least when it came up, I thought, I like that, and I like that for a reason. When we look at our armed forces, we have a specialist team in there who are trained up to do the stuff that the rest of the army would love to be able to do, but actually this is really a specialist area. I am not suggesting that all leakage jobs are going to be dealt with in this specialist way. What I am suggesting is this, is that we split out those difficult to repair ones, the ones that run for a long time, the tricky stuff, and we say, right, let's get some specialists together. Let's put together specialist teams that can deal with those jobs, that can deal with those and put them together so that we do the whole planning regime, so that we do the whole regulatory bit, so that we do all of that better. What will then happen is exactly the same as happens in the army, which is the specialists learn how to do it, and then they pass the expertise down into the rest as well. And the idea of this specialist team is actually, it's not just that they're going to be working in isolation, that they will then pass their expertise down into the rest so that all of our contractors start to work quicker, that we start to speed up repairs because we're learning how to do it better. Similar to the Croydon Group. Now, yesterday I mentioned the Croydon Group and I told you this was water companies coming together with their contractors as well to work out how do we solve supply pipe leakage. And I want to do exactly the same thing here. I want to set up a group within the water companies where we draw us together and say, right, okay, let's solve repairs together. So, Yorkshire, if you've got great insight and great learning and understanding in certain areas, brilliant, let's share that. Okay? Anglian, if you've got fantastic insight in another area, let's share that and make sure that everybody understands together. As I said, the idea is to concentrate initially on the difficult to repair bursts, but these techniques that we're going to be coming up with, these solutions that will come through, will then trickle down to the rest of the industry as well. Needs at least 5 disciplines in there, and this is why I said it's multidisciplinary. Planners. We need people that can identify quickly this is a tricky job. Those are your people that look at this and just go, oh, blinking heck, it's a nightmare. Look where that one is. You know those people in your teams. Those ones who are just going, right, okay. The ones that you go to when you've got a difficult job, you go, can you look at this one? Those are the kind of people we need in this team. We need some really good planners. We need regulatory people. There's going to be water quality issues. Tim was talking earlier, obviously, about our no-dig solutions and things like that. We know that water quality is going to be an issue. But also, regulatory is about dealing with the councils, where you turn around to the councils goes, I'm sorry, these are what the rules are. This is how I have to operate. We need people who actually understand those rules and go, yes. But there are exclusions to those, and this is where we want to work as well. Okay, what if we did a small hole? What we call low-dig solutions. What difference would that make to your council regulation if we could do that? So we need people that understand that regulatory side. We need interruption specialists. So with the 3-hour interruptions to supply, we need to make sure we get that water back on quickly. So there's a lot of work that goes into saying, okay, how do we interrupt that in such a way that we can carry out that repair quickly? Yeah? How do we do overlands? How do we do bypasses? How do we manage that interruption so we can actually work upon that pipe when we want to? Obviously, men's specialists. Really interesting. So at SES, I've been introducing some new products there, and I was chatting to the crews and asking, how's it going? And I love sitting there and just listening to the chat. I move around the company. There is a standing joke in my company that no department can stand me for more than 2 days because I move around and sit in different departments so I can hear what's going on. And I was listening in on the guys on the crews, and they were talking about what they're doing. And they were talking about a job that had gone wrong. It was one of the new clamps we've been trying out. It didn't work properly. And the response was, yeah, well, that was Joe. Joe never does the talks right. Okay, the point is actually there's guys out there that know properly how to use the torque wrenches, making sure everything is cranked up correctly and tight and everything like that. Sorry, that wasn't actually Joe. I changed the name. But the point behind it is you will find that you've got people who are really good at doing repairs. And so we get them involved. And then the final one, explainers. And this is the key bit behind special leak services.
This is not an SES project. This is a company-wide industry project. The whole idea behind this is that if Yorkshire, and I'm sorry, I just keep pointing over there because you've got a whole table, it's easy. Yeah? If Yorkshire come up with a really good way of doing an 8-inch cast iron repair that is 10 feet down, they share that knowledge. If South Staffs come up with a way of doing 3-inch AC in 20 minutes, they share that knowledge. As we gain our understanding, as we get this knowledge of how to deal with these repairs, as new products come on board and we try them out, the whole idea of Special Leak Services is we share. And that's why we need explainers. We need people that can go, right, this is what we did, this is why it worked, this is the actual scenario, and this is what could have gone wrong, but this is how we mitigated that. So we need explainers as well. And as you've probably worked out by now, I love a good acronym, and so it spells out PRIME. Okay? That's what we're going for. Okay? Special Leak Services based around planners, regulatory, interruption specialists, men specialists, and explainers as well, who can make sure we get that message out. Now, my plan is at the moment is to get this up and running within the next few months. I've already started talking to some water companies. I am really interested in talking to everybody. And when I mean everybody, I do mean everybody, because I don't think it's just going to be water companies. The Croydon group, the group that works on the customer side leakage, that has not only the water companies, but if you are a contractor working in that area, with a contract with a company, you're allowed into that group as well. And it brings in suppliers as well to talk to that group. Because you know what, if you're a supplier, you could go around all of the water companies and explain what you're doing, or you could just go once to the Croydon group and explain it there. I want to do exactly the same thing here. We've got men specialists in this room who are saying, how do I bring my product in? Brilliant, I want you to bring it to Special Leak Services, so that we can sit there and go through with you and go, right, how can we make sure that we help you? How can we make sure that these technologies are successfully adopted going forward? So, if that's you in the room, please come and have a chat with me. I'm going to be hanging around quite a bit today, obviously, anyway. Or drop me an email. But hopefully, this is going to be something that we're going to start kicking off in the next few months, and this will be next year, we can start reporting on Special Leak Services and saying, this is where it's going. Thanks very much.
Brilliant, thank you, Jez. Very inspiring, and a good practical kind of call to action as well, which is exactly what we need. Right, we've got one question online, and then we'll come to the room. So, do you think difficult job planners need a decision support tool, pre-planning AI?
Good question. I think it may develop that way. And what I don't want to do is immediately jump in and go, here are technologies we're going to use. The whole idea behind this is it should be effectively one of these groups that are looking and going, right, there's multiple technologies. What works best in what situation? When you look at supply pipe leakage, the guys that deal with supply pipe leakage are very, very different because they have a completely different tool set. You know, our mains repair guys, they turn up and effectively they're digging a hole and they're putting a clamp or they're doing a cutout and that's it. Supply pipe leakage guys will have a whole van of tools that they require in order to be able to do that solution. That's where I see this going, yeah? These guys will be able to dig, but that's their last option. What they'll do is they'll look at all the other options and permutations they can do and they go, yeah, we tried that on something similar, so we're going to try that. And I think that's true of the planning side as well. It's not just the excavation side. I think the planners will be the people that we want are the ones that are really innovative, that are going to be going, how can we do this differently? How can we plan this job so that this one is done differently and things like that? So if AI helps us do that, absolutely, but I wouldn't want to just drive us straight down that path and go, yeah, it's going to be an AI solution.
Yeah, makes sense. Yeah, brilliant. Good, thank you, Jez. Right, questions from the audience. Who's signing up for this? Any volunteers? Joe, get a microphone to Joe. Yeah.
It's just a very interesting talk. What happens if we find out that it's actually contractual issues that are causing those delays? And actually, and again, we've all been there. We put KPIs on to our sort of repair gangs to say we want them to be done this. We sort of reduce them, something has to go somewhere, otherwise cost goes up. So how do we, have you got contractual lawyers coming along as well?
So short-term, long-term, okay? So short-term, I think you're spot on. It may even be contract lawyers, but it will have to be looking at those contracts. And let's face it, what I don't want to do, the whole idea of this is not to really go to the contractors and go, the fault is with you. Okay? Basically, what we want to do is incentivise the right behaviours in our contractors. And at the moment, they are doing exactly what we pay them to do. So therefore, what we've got to do is come up with terms and conditions that work for them and incentivise the right behaviours. The big issue that we get with a contractor is they win the contract for a large water company and they go out and hire, buy whatever, 100 JCBs. The last thing they want is those sitting in the yard not earning them money. So you rock up and go, I've got this amazing no-dig or low-dig solution, and they're going, how's my JCB going to be earning me money today? We've got to change how that works in terms of the contract side, and that means working with them and recognising that they want to make money. That's their job as contractors, and yet at the same time we need to reduce those times down. So I agree with you. We certainly need to be bringing that side in, and I want to keep the contractors on board. I don't want this to be seen as being something that's fighting them. But that's my short-term solution. Long-term. So a lot of our contract conditions come out from the Institute of Civil Engineers and their conditions of contract. So in fact, I've already started sitting down with them and saying, how do we bring innovation into your contracts, your standard conditions of contract that go out there? And they're really interested in that. They think there's a way of introducing those into their standard clauses that would drive innovation and an innovation adoption as well. So I've already entered into those discussions. And again, if you're interested in joining me in those ones, Joe, I'd be really happy to have you involved as well. But I think there's a short-term bit, but there's also, let's be in 5 years' time, when the new conditions of contract come out, it'd be brilliant to see that kind of innovation embedded in them as well, encouraging our contractors to do that from scratch without having to put in specific clauses ourselves.
Go on, Joe, quickly. Yeah.
Taking that then, do we need shorter, like you're on a 5-year contract with Ofwat. Your repair contracts are, if you're lucky from this AMP, some of them are from the last AMP. Do you think then that shorter contracts are needed that better reflect Ofwat's cycle of what you need from the contractors in that respect?
Or the other way of doing it.
Or the other way around.
Yeah, or the other way is to go longer with Ofwat and get a long thing. The reason why we go with non-contracts is cost saving, is because we want that supplier wants to make sure that actually they can budget all the way through and do that. The issue again comes though is how do you change that contract, or how do you bring in change as you go through, and how do we drive those right behaviours? For me, in the time I've spent, kind of in the industry, I've run contracts, I've been out there doing that on the site and working with the contractors and things like that. For me, we're certainly going to have to go through short-term stuff with them to bring in clauses, and particularly where they've got an existing contract to drive the right behaviour. But yeah, I think we may have to look at contract length. And I think particularly, as I said, is this bit about our contracts don't incentivise innovation coming in. We've got to change that. If we can bring it so that those contracts provide that incentive mechanism, then actually the length of the contract is less of an issue, because there is that bit embedded in it that says, no, we will be encouraging you and rewarding you as a contractor for bringing in new solutions and invention within your area.
Brilliant. Great. Thank you, Jez. Yeah, we'll stop there. But yeah, food for thought as we go into the break. But thank you, Jez.
Cool.
Right, we've reached coffee time, so we're going to take a 30-minute break now for networking, refreshments, discussions with the exhibitors. We're going to restart promptly at 11:30, so please be back in your seats for then, for the Operational and Technology Development Forum. Thank you.